Now let's move on to the next proof. We have a different diagram here. We see that we've got a given that A is parallel to B, line A is parallel to line B, so we can write little parallel arrowheads there to remind us that A is parallel to B, and that the measure of angle 1 is equal to the measure of angle 3. We can write in some notations there to remind us of the fact that those two angles are equal. And given those two facts, we are supposed to prove that line C is parallel to line D. Okay, so that we have to go ahead and fill in the blanks in this proof. You can see this is a relatively short proof, so the conclusion follows fairly quickly. But let's see how this proof evolves. So the first statement is that A is parallel to B, and that we have because it's given. And then we have the alternate interior angles theorem, okay, which I'm just going to write rather than using this little symbol, which is saying that parallel lines imply that ulterior angles are congruent. I'm going to just sort of rewrite that as saying the ulterior angles theorem says that if two lines are parallel, then the pairs of alternate interior angles are congruent. Okay, but all I really needed to put down here was this, the alternate interior angles theorem, or a statement that said that that the alternate interior angles of two parallel lines cut by a transversal are congruent. I could have said this in many different ways, but the easiest would have just been to say alternate interior angles theorem. Okay, so that means that we have to start with two parallel lines, and then we've got to find alternate interior angles. Well, the only lines that were given a parallel are A and B. So we've got to take a look at A and B here and try to see, well, which pairs of alternate interior angles are we talking about? Well, actually, we're being told right here which pair. Well, actually, we're not being told. Okay, we have a gap here. We've got to figure it out. It is either, well, A and B are parallel. What are the two transversals? There's this transversal on the left, and then there's this transversal on the right. And the only labeled angles, and here is a little bit of a hint, the only labeled pair of alternate interior angles that we could see is this 1 and 2. The diagram did not label in the alternate interior angle for angle 3, which might be up here, and the other pairs of alternate interior angles, such as this one to the left of 2 and this one to the right of 1, are not labeled either. So we're kind of guided by whoever it was that made up this proof. They sort of labeled only one set of alternate interior angles for us, and that's angle 1 and angle 2. So we could be pretty sure that this means the measure of angle 1 is equal to the measure of angle 2. I want to point out something subtle here. There are two ways to say the alternate interior angles theorem. I said that if two lines are parallel, then the pairs of alternate interior angles are congruent. I could have also said they have equal measure. Okay, I will accept generally either formation of the alternate interior angles theorem. And here we're using the fact that the definition of congruence is that they have equal measure. So we're taking the second definition of the alternate interior angles theorem, and we're directly concluding that the measure of angle 1 equals the measure of angle 2. Okay, so now let's see what we've gotten. We've got A is parallel to B. We then have measure of angle 1 is equal to the measure of angle 2. And now we've got the measure of angle 1 equals the measure of angle 3. And why is that? Why is the measure of angle 1 equal to the measure of angle 3 here? Does it follow from the diagram? Yeah, right? That was one of the givens. Okay, so sometimes you can lose track of your givens, and that's why you kind of write it on a diagram, and that was a given. So that's why we can say that. And let's look at number 4. The measure of angle 3 equals the measure of angle 2. Well, again, you might look at the diagram and say, these look like corresponding angles, and corresponding angles and parallel lines are equal. But we can't say that here. Why can't we say that? We cannot say yet that angle 2 has the same measure as angle 3 because the transversal is line B and the two parallel lines would be C and D, but that's what we're trying to prove. We're trying to prove that C and D are parallel. We weren't given that. We were given that A and B are parallel. Okay, so the only corresponding angles we could use are the ones that are formed by A and B intersecting a transversal. Okay, not B intersecting C and D. It's very important that you realize that. So we cannot conclude that the measure of angle 3 equals the measure of angle 2 from the diagram, because we would have to have been given that lines C and D are parallel. So we must be getting it somehow from the statements that come before. And I think you can see that if you take statement 2 and 3 through transitivity, measure of angle 2 has to equal the measure of angle 3. So this is the transitive property, or it could also be substitution, because we're essentially substituting in the measure of angle 2 for the measure of angle 1 in statement 3, because we know it's true because it was stated that way in statement 2. So then number 4 is either transitive property or substitution. It doesn't matter, they're both correct. And now that we have been able to say that the measure of angle 3 equals the measure of angle 2, we now know that these two angles are congruent, they have equal measure, and we can use the converse of the corresponding angles theorem, okay, which says that if corresponding angles are congruent, then the lines are parallel. Okay, then C and D would be parallel. So here we use the converse of corresponding angles theorem. And that would be the statement that if corresponding angles have equal measure, then the two lines are parallel. Okay, and that allows us to conclude that C is parallel to D. Okay, so let's recap this proof again. We were given A is parallel to B, and that the measure of angle 1 equals the measure of angle 3. We brought those two statements in here in numbers 1 and number 3. Those were our given. We concluded, because of the alternate interior angles theorem, that because the two lines A and B were parallel, the measure of angle 1 equaled the measure of angle 2. And then through transitivity, with what we were given, we were able to conclude that 3 and 2 had equal measure, that those two angles here had equal measure, and because these are corresponding angles with equal measure, therefore that implies through proof, through the converse of corresponding angle theorem, that therefore lines C and D are parallel.